So some months ago we did a demonstration of the assembly of this particular robot arm and a quick demo of how we can connect it up using a serial Wombat chip. Let's take a look at two things. Number one, the hardware we're going to be using, and number two, the conventions that we're going to use. First, we've got a power supply. This is an off-brand power supply that I got from Amazon. I like it because it displays voltage and current along with a graph on the front. Haven't had it calibrated or anything like that, but it's been good enough so far. We're going to be running our servos at 6 volts. Here we can see we're using a serial Wombat 18AB that's running firmware 2.1.1, and it's on a prototype board that I created that's doing UART to USB conversion using a converter chip. The pins run down to one of the servo boards that I sell on Amazon. I find these to be very convenient. They allow you to connect up on one end the signals that come in from a single board computer like a Arduino or serial Wombat chip, and then they have on the other side servos that line up and a convenient place to run in power for all of them. So on this particular robot arm, we have 6 servos: the gripper, the wrist flex, the elbow, the shoulder, and then the shoulder rotation. So right off the bat, let's create some standards. This will help us later when we're doing programming. First, we will say that we start numbering them by the servo that is closest to the end of the arm. So this will be our highest number, this will be our lowest number, and then we'll decide what pins to put them on. Second of all, let's describe positives. Positives will always be as looking out the end of the arm. So typically when you look at a polar graph, or if we look at a graph in terms of radians, as we rotate to the left, that's positive. As we rotate to the right, that's negative. I don't know for sure which way the servos go as we increase our pulse width, but we'll correct that in software. Second of all, positive will be moving towards the sky. The robot arm basically has about 90 degrees worth of operation, and so that as it moves towards the sky, that will be positive. Again, we may have to reverse some of our servos to make that happen. Finally, the shoulder can move, and as we look up out of the arm, to the left is positive based on our convention that looking up out of the arm is positive. Finally, the gripper, it makes sense that 0 would be totally closed and open, positive, would be whatever the range of the gripper is. So those are the conventions that we're going to be using. You may have noticed there's one more board down here, and this is kind of interesting. We'll get into this one a little bit later in the future. This is a current measuring board, and we're going to feed that into pin 19, which is one of the analog to digital converter pins on the serial Wombat chip. That pin is measuring the amount of current used by the gripper. And the idea behind that is as servos push harder and harder trying to close, the amount of current that they use goes up. So what I'm hoping is that in the future, when we put a object in there and try to close it, we can tell when the gripper has managed to grip that object based on the amount of current going through that particular servo. So I don't know if that'll work or not, but it feels like maybe a good way to do some force feedback, and if that's or some feedback control, and if that works, maybe we can use the PID control on the serial Wombat chip to make that happen.
The serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485. as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.